Hello and welcome back. In the last video we introduced if statements, and we mentioned that an if statement can determine which block of code gets executed dependent on conditions in our program. Each block of code can contain any sort of statement in Python. So that might be print statements, assignment statements, function calls, method calls, and so on. The code inside the block could also contain further if statements. So that's the topic of this video on nested if statements. In other words, if statements that include if statements, potentially including if statements. So we're going to look at that construct today. Really, there's nothing new to learn here because last time we said any block of code can be contained within an if statement. So if you're okay with the concept that if statements are just another type of statement, then there's nothing new to learn here. So hopefully it's not too surprising, but we're going to do it with a slightly more complex programming example. So as the lecture notes here say, the conditional code blocks can contain any type of statement, including if statements, and these are called nested ifs, an if inside an if. So our example, the worked example, hopefully you're a little bit mathematically inclined because we're going to be writing a program to solve the quadratic equation ax squared plus bx plus c equals 0. And we're going to look at both the introduction of nested if statements and we're going to look a little bit at how we go about solving computer program problems. So you may remember from high school maths that the solution is x equals and then this equation over here, minus b plus or minus the discriminant, which is the square root of b squared minus 4ac, and all of that is divided by 2a. Okay? So our program is going to prompt for a, b, and c, and it's going to print not a quadratic if a is 0. Otherwise, it's going to print what the roots are. The roots are to 4 digits of accuracy if the roots are real. And it's going to write out that or print out that the roots are imaginary, otherwise if the roots are not real, which occurs if the discriminant b squared minus 4ac is negative. Okay, so before we get to this, I just need to introduce one more quick concept, which is the fact that if you want to calculate the square root function, well, somebody else has written on your behalf a useful set of functions, mathematical functions, that you have access to, but you only have access to them if you import the math module. So in order to solve this, you need to know that you can import math, and that then adds a name to the computer's dictionary, and that dictionary refers to a whole set of code that's available within the math module. We'll look more at packages and modules later. But having done so, we can now use a function defined in the math module, which is called sqrt for square root. So hopefully you're familiar with the square root of 16 should be 4, and yep, the math module gives access to the square root function that calculates this value correctly. So math.square root of some other value that might be slightly harder for you to predict the answer for, well, there it is. The math module does it all for us. Okay, so 2 steps there. First was to import math. Having done that once in the program, we have access to all of the functions available within the math module, and then we can call it by prefixing the name math onto the various functions that are available. We'll look more at importing modules later, but you need that for now. Okay. So if we were to try to solve this problem, and it's a much bigger problem than we've looked at so far in the course, how would we go about doing it? Well, one of the best strategies that computer programmers use is to write out some pseudocode. So pseudocode it's sort of halfway between English and program code, and the idea is to formalize your thinking a bit before you actually go around writing the solution out in Python. So we draft what's called an algorithm, and an algorithm is the series of steps that are involved in solving a problem. And we're going to draft it out in something a bit like English and a bit like program code. Pseudocode is flexible. It's just something that helps you think about the ways to solve your problems. So pseudocode shows the main blocks of codes, the steps that are taken, any loops that might be there, although we haven't introduced loops yet, and the if statements that we might be using. It omits most of the code details. But here's how I would go about executing solving the problem for the quadratic. So we're going to input a, b, and c, and that might come in the form of parameters to a function, or it might come, well, it's going to have to eventually come from the user. We're going to need to prompt the user for this. So we're going to input a, b, and c. Then our algorithm for the quadratic is, if a is 0, we're going to print out not a quadratic. That's more or less what the requirements for the for this program said on the previous slide. Otherwise, so if a is 0, we'll do this. Else, in the condition that a is not equal to 0, we've got a series of steps to execute, and I'm going to break the problem down as follows. I'm going to compute the discriminant, which is b squared minus 4ac. Then, if the discriminant is not negative, I'll compute and print the roots. Now what you see here is I've got a block of statements that are only executed in the case that a is not 0. So all of these statements are contained within the else branch. And inside that else branch I have another if statement. So this is a nested if. If the discriminant is not negative, I'll compute and print the roots. In the case that the discriminant is negative, I'm going to write out that the roots are imaginary. Okay? Now, how do we know that one if statement or one series of statements within a block are included within another? Well, it's the indentation that resolves that, okay? So we can see all of these statements are indented inside the else block, so we know they're contained inside the else. And we know that this statement, to compute and print the roots, is contained within the branch of this if statement where the discriminant is not negative. And this print the roots are imaginary is contained within that else condition of the if statement. Okay, hopefully that makes sense to you for now. In the next short video, I'll show you how I've actually resolved that. So you should give that a go before we move on to the next video. Thanks.